In this module, you will learn about errors in measurement. Consider an object whose actual length is 32.56 mm. Measure it with an instrument that has a resolution of 0.1 mm. The measured value is 32.5 mm. When you measure the same object again with the same instrument, the length is found to be 32.6 mm. This variation or uncertainty in measurement is known as error in measurement. In general, errors can occur due to a fault in the measuring instrument or a faulty technique of measurement. At times, an error in measurement is also termed as deviation from actual value. Errors are classified into two types: systematic errors and random errors. Generally, we study random errors and errors that occur due to limitations of measuring devices in a given situation. The limitation of a measuring instrument is known as its least count, which is the minimum magnitude that a particular instrument can measure. On the other hand, random errors are errors that cannot be associated with any systematic cause or a definite law of action. These errors generally follow the Gaussian law of normal distribution. In a normal distribution, the measured values of a quantity denoted by delta x lie on the x-axis, and the frequency of occurrence of the measured values are plotted on the y-axis. The Gaussian law of normal distribution indicates that the probability of an error, delta x, for a particular measurement is same on both the sides of the axis. In the graph, you will observe that errors of small magnitudes are more common than errors of large magnitudes. The peak on the y-axis is known as the mean of normal distribution, which can be taken as an estimate of the true value of the measured quantity. Mathematically, the mean x bar is equal to sigma x divided by n, where sigma x is the sum of all the readings and n is the total number of readings. We generally take several readings, at least 10, and calculate their arithmetic mean to minimize the random error. Let us consider a copper wire and examine the set of readings of its diameter, which is measured with a screw gauge. Let us calculate the mean of these readings by using the formula mean x bar is equal to sigma x divided by n. Now, let us calculate the deviation for these measurements by using the formula deviation is equal to the measured value minus mean value. There are only two significant figures in the readings. Therefore, we can allow two significant figures in the mean. Thus, the mean value is considered to be 0.92 mm. The maximum deviation in the deviation column is considered the maximum probable error. In this case, it is 0.03 millimeters. Note that we have considered only the magnitude. Hence, the measurement of the diameter of the wire is 0.92 plus minus 0.03 millimeters. Therefore, the diameter of the wire is between 0.89 millimeters and 0.95 millimeters. Note that only the last digit that is subject to error needs to be quoted. If the error is in the second decimal, then you need not quote the third decimal. Hence, the mean value is considered only with two significant figures. Let us now see how to find the error when all the readings of the diameter of the wire are similar. To determine the error, we use an instrument that has a least count that is half or less than that of a screw gauge. The error would be reduced drastically to 0.005 mm, thus increasing the reliability of the measurement. Therefore, we can say that the least count of the instrument plays a significant role in determining the error. Random errors can be reduced by taking a large number of readings and calculating the arithmetic mean, as well as estimating the true value of the measurement. The true value is measured by taking the largest value of deviation as the maximum probable error. You have now reached the end of this module. In this module, you learned that the variation or uncertainty in the measurement of a physical quantity is known as error in measurement. Errors are classified as random errors and least count errors. Random errors follow the Gaussian law of normal distribution. Random errors can be reduced by taking a large number of readings and calculating their arithmetic mean. By taking a large number of measurements of a physical quantity, a mean value close to its true value can be obtained. To reduce error while measuring a physical quantity, an instrument with a smaller least count is preferred.